Welcome. It's a Thursday. So, as ever on a Thursday, this is the MongoDB TV Cloud Connect show. For new viewers, I'm Shane McAllister. I'm a lead on the developer relations team here at MongoDB. For regular viewers, welcome back. It's good to have you. We live stream Cloud Connect every Thursday on YouTube and on LinkedIn. So, do check out the past shows that we've had and also keep an eye for forthcoming episodes. Every Thursday, you will see a new episode from us with various partners. While we're waiting to get underway, let us know, as I've seen some of you have joined in already, where you are and where you're coming in from, and we'd love to hear from you. And once we get underway, do use the comments both in LinkedIn and YouTube to ask any questions that you have for our guests today as well too. Drop them in the chat and we'll try and answer them live as well. It is being recorded, so don't worry if you missed the start, and it will be available after the show finishes on the MongoDB YouTube channel. So if you can't stay for all of it, you can catch up later on. If you're not joining us live and you're watching this as a recording, obviously we can't comment on your questions in our chat, etc., but do leave some comments under the video itself, and we will take a look at those and try to respond. Also, if you haven't already, please like and subscribe on YouTube. We really do appreciate that as we try and grow our audience. Anyway, this Cloud Connect is all about AI. It's everywhere these days. There's a lot of buzz. And if you've been tuning into some of our prior content on MongoDB TV recently, we had Jesse, a colleague of ours earlier on, talking about Gen AI and vector search. Mirror the week before, we did pretty much the same thing using some other demos as well too. And this episode, we are focusing particularly on generative AI. And it's a hot topic. And as ever with anything hot and anything new, it's not particularly clear maybe how to practically go about using it. So before I get any further into this, I'm going to bring on my colleague Dominic and also from AWS, Igor. Welcome both. How are you?
Well, hello, Shane. Long time no see, Dominic.
Hey, how's it going? Good to be here again.
So
Yeah.
for our audience, I suppose, Igor, you've been joining us before. Dominic is always on our AWS Cloud Connect, but maybe for the audience that mightn't be familiar or new people, Dominic, why don't you just introduce yourself and tell us what you do here in MongoDB, and then we'll jump to you, Igor.
Sure. So, hi everyone. My name is Dominic. I've been at MongoDB for roughly 3 years now. I originally started as an engineer, which is still kind of like my focus, but I'm part of the developer advocacy team now, closely working with AWS, which is why Igor and I reappear together on our streams. And that's your transition, Igor.
Oh, is it? Oh, I was thinking like some metaphor, like a bad penny. You keep turning up, Dominic and I, or two bad pennies. I don't know what to do. What you say over there overseas. Anyway,
well, we do hold a record of probably the longest episode of MongoDB TV Cloud Connect. I think we did 2.5 hours building our Leafsteroids game. So if the audience want to go back and go through that, it was great fun. That's why it took so long to do. It was great. We built it. Dominic and Igor built it from scratch. So do have a look at that past episode.
That was a big one, yeah.
Anyway, I'm going to introduce myself, Shane, right? So Igor Alekseev, Partner Solutions Architect at AWS, working very closely with MongoDB. And I'm happy to be a reoccurring, repeating guest. Yes, I was on that Listeroids inaugural show, Death March, you can say, which we survived. But Dominic did not come out unwounded, unharmed. But
yeah,
it was
well, out
great
of that
fun.
episode, yeah, well, not from the next episode we did last week at the conference. So I might still sound a bit like my nose is not in the right place, and that's why, yeah.
Cool. So, shall I share my screen, or should we just continue talking?
Yeah, no. Well, look, as I said in the introduction, we're going to dive into generative AI and some examples, etc., as well too. But I think actually it's great, Igor, if you can share a bit of an insight into AI and ML in particular as well too, obviously from an AWS point of view, all the various tools and products that you have in this space.
Yeah, I have a little couple of slides prepared, but generally speaking, we have several services dedicated to generative AI. Most prominently, Bedrock has been GA'd recently, so you should all have it in your accounts. Just go to the console, type Bedrock, you'll get to it. It's a higher level service, and I'll talk about this a bit in a demo, in a presentation. I think MongoDB developers, that's your primary audience, hopefully, for the show. And actually, it is what I see at a event, MongoDB events. It's primarily developers who come in. It's a good time to actually be developer because for a while, data scientists kind of took the crown. But with the large language models, the focus is shifting more towards engineering and towards developers, because training large language models is a big undertaking, and when there are already pre-trained public models, it's engineering work to take advantage of them. And AWS has great models deployed, a variety of models deployed in SageMaker Jumpstart, and many models available from companies like Anthropic via Bedrock. But variety of use cases are appearing. Definitely a lot around the text. So if you have some kind of text, large amounts of text, free form text, that's a great use case. If you have any customer support situation and you need to generate emails, response to customer queries in automated fashion, those are all great use cases for generative AI. But beyond just text, you can also do audio and video. But today we're going to focus mostly on text.
Okay. Perfect. So you have a slide, I think, too, which kind of shows the AWS ecosystem in terms of AI and ML products, right?
Yes,
you want to
yes.
throw that up on the screen there?
I'm frantically sharing my screen, so hopefully you should see how MongoDB and AWS
There
work
we go.
better together. Yes, we are great partners. We collaborate constantly. I am on Slack with Dominic probably too many times. But anyway, yes, Dominic. First, I want to quickly introduce AWS AIML stack. So 3 sections here. So the bottom one is for advanced practitioners, advanced data scientists, where they are optimizing for specific hardware. So like we have AWS Inferentia or Trainium. These are customized hardware type of solution. It's like actual silicon chips. One is for training, the other one is for inference. They pick their own training algorithms. So they pick their own frameworks. They manage the dependencies. Managing dependencies in Python, a lot of fun, as everybody knows. And they did this. And then as we go up one level, that's where SageMaker sits. And with SageMaker, you have a more managed environment. You interact with SageMaker via APIs. You create jobs that do the training. You deploy to the SageMaker endpoints. So these endpoints are deploy your model to the endpoint, and the endpoint is responsible for inference. While at the bottom layer, you would be writing code yourself to do inference and doing the scaling yourself. SageMaker endpoint auto scale. And in the top level, we have what we call AI services. These actually arguably is the easiest way to add AIML capabilities to your application. If you have an app, mobile or web-based, and you want, for example, add recommendation, then you quickly you can add personalize. So customers who clicked on this most would like to maybe see this. Or if you're worried about fraud that's happening with the users interacting with your the application, the mobile side, you have fraud detector. All of these applications are kind of unique in the sense, not unique, but the way to integrate with them is primarily engineering effort. It's APIs you're integrating and a data preparation. You need to give them data set in the right format. Does it make sense, Dominic, to you and Shane? Like, is it overwhelming, underwhelming?
I'm fine with that structure, but I've seen parts of it before, so I guess it's a bit easier for me to understand that it might be than it might be for others. But I guess those 3 layers are pretty clear, and the abstraction and what builds on top of each other. And there are a lot of services that are like part of that, and I guess not all of them will be known to the whole audience, but that's just what it is when you work with AWS. You guys just got too many services, and it's impossible to know them all, because you solve basically every single problem that exists in the internet out there, right?
Yeah, it's all about customer choice. Yeah, we wanna make sure everybody has a product or a service that they can take advantage of.
Or even multiple, which is what I really like, that there's several different approaches, or like approaches built on top of each other, which we had in for leaf steroids, where we talked about Beanstalk, which uses EC2 under the hood and things like that. So it's really cool, because you can always find the right thing.
Yeah. And then like the overall trend, of course, is towards a higher and higher level of abstraction. And that's what you see on this slide. So the higher level services, they are farther away from training. So you don't need to know algorithm or model, don't need to be a data scientist, but you need to know the service specifics. Cool. I want to quickly pivot. Oh, yeah. Just quickly, I want to talk about some SageMaker, because that's a lot of things happening there. That's a great service if you have data scientists, but you don't have to be a data scientist. So, like, there is a service canvas at the bottom here, which is primarily for analysts. They can do point and click, train the model, see what affects the model performance, what specific prediction is made in such a way, which features impacted. But generally speaking, you can prepare a data with SageMaker, you can build the models, you can train and tune them, and you can deploy them. Today's primarily we're going to focus actually on generative AI, and we have several services, and we also have specialized hardware. So I mentioned Trainium and Inferentia are the specialized silicon chips for training models and doing inference on data. Bedrock is the newest service that we just launched. Is the easiest way to start with generative AI. You interact via APIs with large language models. And Code Whisper is an example. It's almost like it's an application that is built on top of LLM, not too dissimilar to what you will be building as developers. You'll be building applications with generative AI capability. So Code Whisperer is a kind of coding companion. It plugs into Visual Studio Code. It plugs into IntelliJ, and it can help you kind of generate code as you type based on the comments that you have and on the code itself. But today we want to focus mostly on the SageMaker Jumpstart. Maybe in the future we'll do another show on the Bedrock. Jumpstart is a service where you can, it's part of the SageMaker. That's why it's called SageMaker Jumpstart. There is a collection of solutions, models, existing models. You can search through them. You can find them, several LLMs there. You can easily deploy. There's like a button there, and they typically come with a notebook that is already pre-configured to play with the model, so you can quickly experiment. Some of the models can be fine-tuned, customized, and you can also deploy these models to production. There are several models available. Llama 2 from Meta is the most recent addition, but in today's demo, we'll be using models from Hugging Face. We use Flan T5, and we'll use the Hugging Face embeddings model as well.
Okay.
Some of the models publicly available, some of them are proprietary models, and I guess that's a difference between SageMaker Jumpstart. You have a broader variety of models, and then in the Bedrock, you will have more vetted and curated models.
Okay.
All right.
Igor, would it be safe to say that, obviously AI has come to the fore in the past 9 months, a year, a bit more than that. And the key thing about this is just get started. Try and experiment. SageMaker is a great
Yes.
place to go and do that and see the models that are there and play around with it. They're, all of this is so new. Don't be afraid to kind of put a toe in the water and get started. And that's what you have up on SageMaker there.
Yeah, absolutely. You can start with the SageMaker Jumpstart. It's super easy. You just go there to the UI, you'll search, open the SageMaker Studio. In SageMaker Studio, just open Jumpstart, and then just search for what you're looking for, like some kind of solution, text summarization, or financial fraud, or in there's some. It's not only models. There is full solutions there as well.
And you don't need an AWS account to get started there, do you? Can you get started with the developer IDs and things easily for free?
With Code Whisperer, yes, you can start
Okay.
with developer ID. With SageMaker Jumpstart is available through the console. But we have another product where you can play with the models.
Okay.
I think SageMaker, I have to double check. It's either Labs or something like that. SageMaker Labs. I have to double check the name of the product.
No
But
worries.
there's one to play. But Jumpstart is through the console. So that's kind of the flow, which you're going to have with this Jumpstart. You're going to provision a model, then select first a model, then deploy it, and then you can play and fine tune it. And actually, this slide, I want to just quickly kind of I want listeners to have, viewers, I guess. They have this mental model. So there is a cost attached to training models from scratch, right? And large language models, particularly, um, they're trained on the corpus of Wikipedia and everything that could be crawled publicly over the internet. So it's not insignificant. And
They're
but
huge, right?
yeah,
Let's just say they're enormous. And unless you're an enormous company or a huge amount of developers all gathered in one room, the usual infinite amount of monkeys with infinite amount of access to computers, you're not going to make your own, right? You're going to leverage one of the pre-existing LLMs, right?
exactly, because they all trained
Mm.
on the same data. It's publicly available data. Why would you want to retrain? I mean, there
Exactly.
are situations where you want to retrain. Maybe you're not happy with all the inappropriate language that is internet full of. I'm pretty sure Dominic is spamming some people out on Twitter, or
Oh, for sure, always.
are you always polite, Dominic, when you interact on the internet?
Of course, I would make it through all those filters.
Okay.
It's
And
always
if you have a
fine.
particular use case, it's the second row there. It's the retrieval augmented generation that helps you for those specific use cases that sit on top of the LLMs.
That's right. That's right. Exactly, Shane. You don't have to train the model from scratch. You can take an existing model and supply additional context. So basically, the cheapest way, actually, let me jump back, is prompt engineering. You massage your prompt, figure out like what's the uh, uh, by massaging the prompt, you are able to get the response you want. That's cheap because you don't train in the model, you're just playing with the prompt. With retrieval augmented generation, or RAG, you can uh, give model additional context and tell model to answer only based on the context. So model has developed, as through the training, it has some language capabilities. So it can figure out things, can almost like logical reasoning is there. So based from the context, it can answer the questions. Instruction fine-tuning is mostly focused on improving like the first answer, zero-shot performance. So the first answer is the right answer, so you don't need to have a long dialogue. Fine-tuning is when you take an existing model and you give it additional data. So basically, like they might be chopping several layers of the neural network, and this additional data is the one that will be provided to the model and will help answer the question. This is helpful maybe when in your domain you don't have enough data to try to train large language model, but you still want to answer questions. And then there's the most expensive one is retraining the model from scratch. In this case, you need to have like a proper data pipelines collecting all of this data from everywhere and then training it. And the judgment, I mean, it's still not like it's very, Shane, like you said, it's early days. So this is a scale. Where you want to be in the scale is kind of up to you in terms of LLMs. Do you want to? You may
Sure.
train yourself. You can use. We have hardware to help you. You want to do retrieval augmented generation, then you can do it as well, and it's not as expensive.
Okay. We got
I
2 questions, Igor, if you don't mind me interrupting for a second.
Sure.
One was about how do you protect sensitive data as the
Yes.
input to some of the services?
Right. So first of all, these models that are deployed on AWS, they are deployed privately. They are
Mhm.
attached to your account. They're not shared. The model is deployed to your account, and so that's security like overall. Now, if you're asking about protecting, so when you send the text to this particular model, and we are not logging the text, its model is fully under your control. Now, there is another security aspect: is what if like you have several users, you deployed an application, and several users are asking questions, and that's where retrieval augmented generation plays a role, where by controlling the context that you supply to the model, you control the security. And that makes sense intuitively. You do not want to give patient information from patient A to patient B, right? So like you will tightly control that context. And the model should not have any other context. So that's kind of another advantage of retrieval augmented generation, that you can control the context. It's an yeah. And then
Okay.
so
Okay,
that's
that makes sense. And a second question, which I think the name gives it away in itself, the large language models, but they're not local at all. Are they, it's always an API call, essentially adjacent. Now, retrieval augmented generation is a slightly different process, but it's an API call, right?
Yes, the models are deployed, like in a case on AWS, it's a model deployed to an endpoint,
Mhm.
backed by hardware, and you're not running them on your laptops. Some of the models getting so large they will not even fit the memory. So
Mm.
there is like a whole topic of optimization of the models, optimization, how many layers it has, what kind of integers it uses, like almost engineering tasks. Int 32 versus int 16 versus int 8. Yeah.
I guess the background here, or what our users might be interested in, and to be fair, me too, a bit, or I'm not sure about it. How large are those models actually? Like, how much space are we talking about? How much memory do you
Um,
actually use for that?
well, you think about like the Llama 2, it's 70 billion parameters.
Hmm.
And that's and in
I'm pretty
parameters,
sure parameters is something that many users might not, or viewers right now might not even be familiar with how that maps to how much space is that, how much storage do you need.
some of them go into gigabytes if you want to kind of get it into the, like, because there's like NVIDIA talks about how you can chop up the model and split it. Yeah,
Hmm.
it goes into gigabytes at this point. Parameters are, you think of them of like numeric numbers, weights. Um, yeah, they're definitely not running on your like a local laptop. All of these large language models like Chat GPT and application, you're interacting with a backend. And in fact, in today's demos, I'll show you the architecture actually. This is what an architecture looks like of an application running using a large language model.
Hmm.
And this architecture. So if you think there are 3 parts here. So there is the user. Actually, it's a nice segue, that question, into our kind of architecture and our topic. So there will be some sort of user interface or some way of a person to interact with the model. It could be, in our case, it's going to be Lex. It's a chatbot product from AWS. Then you'll have the model, and in this case, we're using 2 models deployed somewhere. So we have 2 endpoints. And then you'll have some sort of compute that glue. Of course, you have a backend. In this case, we're using Atlas, and we're using we're using retrieval augmented generation for this discussion. So Atlas is the backend. You have a compute that kind of glues it all together. So interactions from the user are sent. In this case, we're using serverless approach. We're using Lambda. Interactions from the users are sent to the Lambda. Lambda interacts with the endpoints and interacts with Atlas to retrieve the additional context and generate. And from the model, it gets the responses and sends it back. It could be completely like, in theory, you can chop off the user and you have an API. So just expose it via API, but most likely you'll be building it either a new application or adding the capability to an existing application. So, but these three components have to be there. The models, endpoints. For RAG, you need context provider, in this case MongoDB. You need compute, and you need a user interface. All right, so maybe it's a good time to dive into a demo, and I'll show you.
Excellent. Let's jump out of the slides. Just before you proceed, Igor, just at the bottom of your screen, there's a prompt from StreamYard, this platform. You might hide that because when you jump into your IDE now and things, it's going to probably cover some code. Yep, gone.
All right, awesome. Thank you for
nice
reminding.
And clean. No worries.
I thought that was not visible to the viewers.
It shouldn't be, actually. I mean, it would be clever that it wasn't visible on the broadcast, but yeah, it is. So, but it's fine. It was okay up till now. But if you're probably going to obscure some stuff there.
You're probably sharing your whole screen, so that's probably why it's visible.
Yes, I am sharing my. Yeah, I don't want to switch between windows.
Make sure to not show us something that you don't want to show us.
Yeah, let's switch to the demo. Let's see. Okay, so I have 3 bots, and like what we can. So I'm gonna first, like, if I can draw a circle here, first bot will be interacting only with LLM. Oh, I said no disturbing me. Well, anyway, looks like somebody's ignoring my settings. So first bot is going to interact only with the model. So we have Lex, Lambda, and SageMaker endpoint with the FLAN-T5. That's the model. But model itself is not super relevant for kind of discussion. Second, we'll use second bot, and maybe I'll come back. Let me just first do the first bot, and I'll come back to talk about what the second bot will be doing. So I'm going to quickly go to Lex. And my context here is, by the way, my context, what is my context? Oh, look at that, security. So I am
properly live.
Yeah, I am in my mind right now, because I don't have context. I am talking about movies, and I have a question about movie Samsara. So, but model doesn't know it. So when I say describe Samsara, it has no clue what I'm talking about. It's gonna start hallucinating. So hallucination is just gonna make up stuff. And a dream is a thing that has no beginning. I mean, very philosophical.
Definitely hallucinating now.
I can totally picture the model with a beer and like, what should I respond? Dominic, you can relate to that, right?
Oh yeah, totally. I've seen that before.
Yeah. I mean, it's a long night and long of coding, and you kind of come up with this kind of stuff. So just back to the diagram. So this is, I send a question to the model responded, and that's what it came back with. Next, I'm going to do another bot, but this time I'm going to provide additional context from the MongoDB Atlas. I'm going to use keyword search, because Samsara is the title of the movie. It will find a full plot description, and it's going to answer that question using the plot description. So I'm going to ask the same question: describe Samsara. All right, and after a while, it should summarize me that's what I asked in the prompt. Yeah, a spiritual love story set in majestic landscape of Ladakh, Himalayas. All right, now I'm gonna ask slightly. So what it did, just quickly, basically back to diagram. It went back. I have a full text search index, which Atlas has great feature. I searched for what the user was asking me, samsara. I found a title. I took the description of the movie, pushed it to the model, and asked it to summarize. And that's what model returned.
And
Now,
in the first example, essentially the bottom right arrow did not exist. You didn't have additional context whatsoever.
Exactly.
It went to Lambda, up to SageMaker, and then hallucinated its way into a response.
And this is where you see the difference. So retrieval augmented generation versus retraining the model. So in the first case, in order to incorporate this additional context, I would need to train the model. And the minimum, I'll need to fine tune it. But with RAG, we can add additional context very quickly and easily. All right, so we did this with the keyword search. Now we're going to do it. Now let's see if I ask it differently. So I have this phrase where almost every single word is replaced with a synonym: spiritual, religious, love, romance, plot, story, mountains, Himalayas. It should know. Majestic, beautiful, but it doesn't, because those are the keywords that do not match. So,
and I guess the reason you did the replacement here, if you searched exactly for it, it would obviously work, right? So that's the difference.
well, yeah. Like if we go to the bot again. So this is the yeah, that's the right bot. If when I say describe samsara, because the keyword match is
meant the other way around. So if you actually took quoted basically the description instead of using synonyms,
right?
would that work
Yes,
here,
it will match. It will match, and it should
find
match,
it, right?
But I'm not going to do it on the live show, just in case.
No, that's fine. Yeah.
But it should match because it's looking for the keywords.
Yeah.
It's a simple keyword search, nothing fancy about it. Now let's try with the semantic search. Same question. And with the semantic search, it should match because these are similar concepts. And its advantage of semantic search, you do not need to kind of create dictionary of synonyms, right? That was the solution originally to the problem of synonyms, because some people ask questions slightly differently, right? So that's where we have find samsara. So let's look what's happening under the hood. First of all, I want to show you what the index.
And just for the viewers who joined, and if you like, this is the AWS, this is the console, everything that AWS has is available there. And then the other screen that you slid over to is obviously MongoDB Atlas, which is where the data is stored.
That's correct. Right. This is the data. And yeah, this is like my life. I'm sliding back and forth between.
And this movies database is one of our sample movie databases, our sample databases that we have available to build, any of your projects and proof of concepts against. We've a good few sample databases now, but the movies one obviously is great in this context.
Yes, exactly. I picked the movie database because it has nice long full plot description. And that's what we can, because this is a text paragraph, we can ask it to summarize, we can answer questions based on text. Now, this has this record has a vector, and that's why it's called vector search. Or sometimes you'll hear the word embeddings. So I've generated it, and I'll show you how I did it in a second. But first, I want to show you indexes. So I have two indexes defined here, search indexes, they're called, search indexes. So I have default, which is regular text index, and I have a vector index, and I want to show you what it looks like. Jason. Yeah, so that's what it looks like. So it has dimension. Dimension refers to, actually, pop quiz for Dominic. What is that dimension referring to, Dominic? Take a guess.
That's a good question. Let me see. Because I actually don't know the answer in that case. You picked the one thing that I have no clue about.
There was a vector. There is
the length of the vector.
Yeah, it's the size of the vector. Yeah, exactly.
Should just be that, right? Yeah.
Okay. Yeah. We have to tell the index that how what our vector size will be. And MongoDB supports up to 2,000, 2K, 1040.
But the interesting question now, though, is how did you come up with 384 and why is it not 42?
Exactly, which is answer to everything, right? It should have been
Right.
42.
Could be.
Well, that's a good question. And the number of dimensions
Or
is driven by
56 or 512 at least to have like a power of 2. But why 384?
it is driven
It's
by
not
the
even
model.
prime.
It's not prime. It is
Yeah.
driven by the model that generates the embedding. So in order to populate this vector, I had to, sorry,
So in other words, it's not your personal preference. It's chosen by what you're going to show us, but it's not your
no,
what's the term for that? It's not a proprietary choice. Is that the right term?
it's chosen by the data scientists who trained the embeddings model. It's a choice, like it's a choice that they made, and when creating the model, and we'll go a little bit deeper into this in a second. So they created. So when they chose the model, when they trained the model got trained, and they specified how big they want this output to be, and that's what the model generates. Now, what does it? Let me ask you more question. What does this vector mean? Like I asked about majestic mountains. Can you tell me, Dominic, what are these numbers? Do they look like mountains to you?
No, but there's a different word with M that fits that quite well. That's magic.
Yes,
because
yes.
that's what it sometimes feels like when you look at those models and what they actually do and how that like on a very deep level works. And they basically, I guess the easiest way to look at it is they describe similarities.
Yes.
Do you agree with that? Is that an okay description?
Yep. It's some kind of measurement of similarity. And actually, a big clue should be this KNN. It stands for K nearest neighbors. It's an algorithm in machine learning for clustering. And Euclidean, maybe you remember from math days in high school. I don't know, elementary school. I don't know what they teach in elementary school nowadays. It's the
pretty
distance.
sure that's not what you learn in elementary school. But
well,
yeah,
you learn the Euclidean geometry,
college.
right?
You got to go to college to get into the
Fine
Euclidean
college.
stuff.
Secondary school, university. That's the stuff you learn, I guess.
Yeah. So Euclidean here refers to how we measure the similarity. So Euclidean, you think about the two dots on the plane, right? How close they are to each other, versus like there's another one. It's called cosine, wherein they're mostly worried about directionality. So the two dots may be far away, but if they're pointing in the same direction, yeah, they're very similar things.
We work in a Euclidean metric. Yeah, that makes sense.
And
yeah,
you can choose those, right? So you can do cosine. We also have dot product, which is cosine plus magnitude.
Yeah. So there are different measures. Like there's one called like I think Manhattan or something, like where
I was about to ask that. It's actually funny. I was about to ask you if the Manhattan metric is also part of that, but okay, that's good to know.
Not sure if MongoDB supports it, but it's like there are several ways to measure how similar you are. So roughly speaking, like think of this vector representing of some sort of clusters, right? So like several 384 clusters. And then what we are measuring is how close you are to any of those kind of clusters. And if you're close to the same type of clusters, then that means that the you and I are similar.
Very similar.
If we are, yeah. And that's actually what's happening here. And this number basically represents number of clusters. The more, of course, the better, but then that means we can finally match things. But then at the same time, you get performance hit, right? The more of these things need to be compared, the longer it will take. So there is a trade-off. MongoDB chose to use 2048, very nice round number, and less. So it doesn't have to be specifically. Quickly, I want to show the code, what the code looks like.
Sure.
To generate, it's not a rocket science. So here what I did, I basically looped through all the documents of the database, and I called a method which actually calls to the endpoint, and it uses very specific model. I'll show it to you. It's right above here. So yeah, this is the model. It's just the name of the model, Mini LM from Hugging Face. And I picked it because I know it supports 86, 84. This dimension is 384, and that's what compatible with MongoDB Atlas, and that's what I did. And like the code here, as you see, it's a couple of 2 lines, right? You supply it with a JSON, and you call an endpoint, and then you parse response because it gives you like another object. And from there, so what I'm giving it full plot, and query is basically I send a paragraph, the whole paragraph of text to the model, and it gives me the embedding, and it supports actually batch, and that's why I have to, because I'm sending one at a time. Dominic probably gonna blame me for not doing batching here. I'm doing it one at a time.
Yeah, that's very inefficient update one there.
Exactly. Yeah. I knew you're gonna zoom in on this one, but at least I did like not print every time, right? I see. I did a mod.
But the key thing there too
What-
is that you are making that update back on the collection, back on Atlas. So vector search allows essentially the vector and your data to be stored together.
Yeah, that's a key advantage of MongoDB, because with other databases, they might be purely vector databases. Then you have to kind of have to store maybe another reference to where the data will be, or they might have some rudimentary document capabilities. Here you have full advantage of MongoDB Atlas, and you have this additional search capabilities. Yeah, like you can see, this is the real record. This is it's stored right here. And actually, I started playing with Bedrock, so this is why you see 2 of them. This is regular. This is the a slightly different array.
Work in progress. Work in progress.
Yes. For the next show, that's a plugin for the next show. And so,
and that's really important for the performance here. That and why we keep saying the data that gets used together has to be stored together, or should be stored together.
Yeah, I was going to bring this up, Dominic. You upstaged me. Yeah, like this is the same mantra you keep referring to. Yeah, what's changes together should be stored together. Same thing.
Yeah.
And in fact, in my slide here, I talked about like how do you keep this up to date when your record changes. One solution is using MongoDB Atlas trigger and a special type of trigger, event bridge trigger on AWS. So whenever data changes, you can make a call to this endpoint, SageMaker endpoint with this embeddings model, and get the new value and store. It doesn't have to be a super real time, or of course you can do it like I did in a batch mode once a night. Nightly batches, they live forever. Just quickly, I want to show like what it looks like to interact now that we've updated the records. How do you interact with the vector search capabilities in Atlas? So first, you need to generate an embedding. You cannot send text anymore. That's a different from keyword search, right? Where you supply the text and off you go and it searches. No, not anymore. You need to give it embedding. So you need to give that vector. First, you need to construct it using the same model that you've used to populate here. So I'm using the same methods here. So I call it once because I'm using just this phrase. And this is the phrase I'm using to pull out something from the model. And this is the search syntax. You tell it which vector to use, supply the embeddings, you give it the name of the attribute where the vector is stored. And this is beauty of MongoDB, because you can tell it what to project back, right? You can tell it which attributes of the document you want back. In this case, I want the title and plot. And then it starts returning you results. And that's what it tells you based on the similarity. Like, yeah, I guess it.
So I love you put in creature with amnesia troubles. What movies did it give back to you for that?
Please don't laugh. I was shooting for the Nemo.
I love it.
But
creature with amnesia troubles. Right.
Did it work though? Did you get it?
It's because first of all, I mean, who knows what that embeddings model was trained on?
Okay.
And here yeah. You see, it's amnesia and memory, but it makes sense, right? amnesia, troubles, and wounded. Yeah, it kind of makes sense. But it's not what I was. It's all
No.
because the model itself is probabilistic, in a
I see
sense
the
that
born identity further down there. That's, yeah, he had amnesia, right?
he had amnesia. Yes, yes,
Yeah,
yes, yes. It all kind of
getting
makes
there.
sense. But
Yeah.
in this case, like it's not getting what I want. So maybe I should have trained the embeddings model on this data, but I grabbed the existing ones, and maybe I
Yeah,
need
but
to, I need
in
to have
in
larger vector.
fairness, Igor, Nemo ran away. It was Dory who had amnesia, who kept repeating things, right? So it's not really the main character. So it's okay. It didn't get it, right?
I'm not too deep on this mythology of Nemo versus Dory,
Yeah.
Shane.
You
Obviously,
you can spot the guy who had kids back in the time when Nemo was released as a movie,
yes.
and the DVD is ingrained in my head. Yeah, I can quote Nemo. Yeah.
You can clearly see the rocket science part. It's not the code or embeddings or AI. It's just actually knowing the story of what you're looking for, you know?
Yeah.
Yeah, yeah.
Well,
So
Yeah.
I don't think it was too bad that it didn't find Nemo, because that was like a tertiary or even further down plot, was that Dory couldn't remember things more than 3 seconds, right?
That was a bit around the corner there, so I guess that's fair.
yeah, I mean, I should probably add like more like a sea or ocean. So because the creature kind of can be too broad, right? Yeah. But
And
back
and
to
Amit wants a special show on Nemo versus Dory. Yeah, we
Oh
can
yeah,
do that.
there you go.
all
This is
right.
good.
Yeah, I mean,
Yeah,
sounds like we have enough depth on this
this
show,
is
right?
important stuff. Yeah, I'll
Yes,
create a demo for that one, definitely.
yes, yes. So just kind of to recap, we tried 3 different bots. Each bot interacted with the model slightly differently.
Mhm.
The first bot only used model itself. We had wonderful hallucinations.
Mm.
You can inspirational quotes you can get out of the model. Then we did keyword search, and then we did semantic search. And you saw how. And by the way, you notice there's no data science work here, right? I'm all
Mhm.
coding, updating records, updating objects in MongoDB. I am coding Lambda. I didn't show you the Lambda that interacts.
There was
With
also a question about that earlier. Is that all just one lambda, or do you need multiple lambdas for that? Because that slide is showing like the
3
lambdas
different
in
lambdas.
twice.
Yeah, because
Yeah.
in one case I just send the input directly to the endpoint, and the other one I do a keyword search. Yeah, I did 3 different lambdas. Well,
Okay.
the biggest copy and paste. Yes, the most advanced technique. Yeah, I
Brilliant.
could have probably combined into one lambda, but essentially you will probably, this is for the demo purposes, right? You will be probably having one lambda. It's up to you. Like, this is engineering question. How do you structure your program
Yeah,
now? How
exactly.
do you break it up when you have different paths? You can pass some kind of flag and feature flag and just turn on and off things. Um, and yeah, so and I didn't use event bridge, but I used batch mode to generate the embeddings, which is obviously in production. You will be doing more closer to real time, because as your records change, objects change, you will not be able to find them because your vectors will be a little bit out of sync. And again, it's nice to have MongoDB and
Mm.
the data right next to the vectors.
Okay. Seeing as you're on this slide, we got a question from Edward about explaining how to operationalize Amazon Lex. Can they embed it in a chatbot or a website or similar? Was the question.
I actually, there is a great integration with Slack.
Oh.
So you can expose this bot via Slack. If your company uses Slack, you can just have a like a channel where
Mhm.
the bot will be responding to the questions, and that's going to be powered underneath by Lex. And of
Don't be
course,
giving,
like,
don't
yeah,
be giving Dominic ideas now. He's going to go off and build that for the Dominic Slack bot, and he's just going to be the most productive developer on Slack in MongoDB.
it's going to be
That's
like in
dangerous. Yeah.
Silicon Valley, right, where they build a bot to pretend to be Dominic answering all the questions.
Yeah, exactly that. I like
Yeah.
that.
Excellent. Thanks for the question, Edward.
All right. I don't know how we're doing on time, but
We're good for
I think
time.
we're
We've got
fine.
about 10 minutes or so. We can show some more examples. I'll keep an eye on the questions as they come in as well too.
Yeah, I kind of covered almost. Let me see what else I have. Oh yeah, if you want to see like what's in the bot, I can show what's in the bot. Is very simple. In the bot, I only have like empty intent. Basically,
Hmm.
everything falls through straight to Lambda, and I have a Lambda function that I have here that does a response. So um, intent in Lex terms is like how you interact, like it looks for certain key phrases, utterances, it's called them. You enter utterances, but in our case, everything goes to the Lambda, and Lambda then parses. Now in Lambda, I'm using LangChain to kind of glue it together. There's several frameworks, Llama Index, but I'm using LangChain, and I get the context from the MongoDB, and I construct the prompt with that context, and I'm asking it to use a question based on that context. Yeah, happy to answer questions if any questions. Happy to show other things if any
So you
ideas.
said you were going to start play. You had a vector there for Bedrock as well too in the data set
Yes.
that you had. What were you? Can you talk a little bit of a teaser for maybe a future show about what extra does Bedrock bring into the mix here?
So with the Bedrock, is the difference is that you are not dealing with endpoints anymore. Like if in the diagram here, we interacted with the SageMaker endpoint, and we had to deploy it. There's a little bit of a management, right? You deploy the endpoint, and you say which model to use. With Bedrock, you interact directly via Bedrock client, basically via APIs with the Bedrock service, and you just say, I want to use this model to generate embeddings. And in fact, we were waiting for the new embeddings model because our original Bedrock embeddings model was supporting 4K of vector size. So the new model supports build 1536, I think. Again, don't know what that number means, but it's definitely below 2K, so it's going to be supported by MongoDB Atlas.
Okay.
And then the code is you're basically interacting. It's an API equivalent of a call. And no data science, no training of the model. It's all engineering work, interacting with APIs, making calls, and then
So you can proceduralize and automate more that way, right?
it's proceduralized. Yes, you can automate. You also, because you're not working with a lower level, it's a high level of abstraction. You don't need to deal with individual. You don't need to manage an endpoint, for example. You are interacting only, you're charged on the API call basis, not just like for a SageMaker endpoint. Like when you have lower level of abstractions, you need to do nitty gritty of a particular service or product. With the higher level services, you need to worry about less and less. You're farther and farther away from hardware, and you need to know less and less about the hardware. And you can focus more on the task at hand. That's kind of the trade-off. And if a service does well for you, you can stay with it, and you don't need to drop lower. If does it make sense?
Yeah, I guess the approach is you basically start as far at the top as you can, and only if something doesn't work the way you need it, you just start digging deeper. And
Yes.
at some point, you might have to dig all the way into the lowest level, but if you don't have to and can make a level before that work, or on top of that, if that makes sense, or above that, then you can make your life easier and just stick to that and use it and actually,
absolutely. It's a standard engineering choices, right? Whether you have to choose between writing yourself from scratch or use existing one. And again, if you want to do something quickly, you probably want to reuse existing one. And like Dominic said, throw it away or replace it only when it doesn't meet your needs. In this case, we are using existing models, and with Bedrock, you'll be working with APIs, so it's easier to start with the Bedrock. And we have some good models, so there's some curation, and also you need to have to look through multiple models. Oh, actually, I do have a repo, right? I just remembered. Shane,
oh yeah,
we have a repo. That's right. Let me just, yeah, we had a repo. GitHub. And I know, Shane, if you wanted to highlight that there is this MongoDB partners repo, right?
Mm-hmm.
Yeah, so
So,
we do have a Lambda. I have Lambda code too. I can show Lambda code. Hello world. Hey. Yeah, so this is the, actually, this is the Lambda code, right? So what I'm doing in the Lambda code, basically, this is a Lambda code responding to the Lex event.
mhm.
So the event arrives and I have to pull out like input that the user provided. Then I build a long chain, build a chain using long chain, and I run it. And that's the result is what I'm sending back, and that's what appears in the chatbot. And I'm gonna show quickly what the chain looks like. Yeah, nothing super complicated. Hopefully I didn't hardwire any
Mhm.
credentials here. No, I did. I was a good boy. Atlas URI, LLM endpoint. Nothing is hardwired.
Good.
Yeah.
I can remove the screen if you had to, but yeah, you're good.
Oh, okay, cool.
Nothing
So
hardwired.
what we're doing here, let me just scroll to the bottom. Yeah, this is the run. This is the build chain. So this is where we're constructing. So we're gonna say this is the main. We create a SageMaker endpoint, some
Mhm.
additional parameters, endpoint name, and we supply a context retriever. In this case, it's MongoDB context retriever, and this is for semantic search. And then we have a prompt. This is the prompt actually. It's all English.
Mm.
And then the context will be substituted later when we run the chain, and that will be dynamic. And there's some additional instructions, blah, blah, blah. And the question is we're plugging the question. And the retriever is actually very, very, very familiar. It will be very familiar. So here we're using the embeddings. We have the embeddings model. It's the same model I was talking about, mini-LM,
Mhm.
L6 V2, and you will see a search. So we are using MongoDB Atlas vector search. That's built in into LangChain. It's already built in, so you don't need to you don't need to construct that search query statement. You just need to tell it collection, embeddings, index name, etc. And the only thing extra we are doing here is, and it performs like similarity search. We need to kind of parse a little bit. Yeah, we need to parse out the output. So you need to pull out like the embedding and the text based on the text. This is like transform the input and transform the output. And that's it. And then like in terms of we used PyMongo, of course, to connect LangChain is the overall framework to put these things together. Bot of 3 to interact with Mongo with AWS services, and request is just for HTTP calls. I don't think we've been using, do we use? We might be doing an HTTP call somewhere. Yeah, that's the Lambda level, like a level of complexity. Not super complicated. Like Dominic, you can do it, right? Like you're already like thinking of this bot. So
it's already thinking about the next thing to create with that. That's for sure. The repo is publicly available, right?
No, not yet.
Not
We're
yet.
still fixing it, but
right.
But if you go to the top level, so this is, I guess, a preview. But at the top level, and I know Shane, hopefully you can paste that partner space. That should be available.
Yeah.
Also, I'm using this SAM CLI. I don't know if you've ever heard, Dominic, of SAM CLI. That's awesome. CLI based CLI based application development. So SAM is a serverless. It's a serverless model, but I'm using it because for one big reason, it nicely packages Python dependencies. So like
isn't that something that we all like, because Python dependencies are just
and SAM is awesome because all you need to do is you have that the requirements file, SAM CLI will automatically pick it up and package it the right way and and send it out. And you don't need to do it. All you're doing here is modifying this template and supplying some extra, like, yeah, I had to give you have to give like permissions, a role to call Lex, the role to do inference from Lambda, the standard stuff. And it's not super complicated. There's like additional YAML, and there's this little parameters file. Yeah, super easy. Highly recommended. Yeah, so this was actually what was in the Lambda code. It's not much. I mean, of course, if you add more sources of context, it will be more complicated. But the level of complexity is not overwhelming. And again, no data science code. Everything is engineering type of code. That's I think what should appeal to MongoDB developers.
Yeah, well, I think on when we had our .local London event last week, and one of the guests from RedMonk was I interviewed, and he said that the new programming language is English. So we're abstracting away things further and further. Now, look, that's an entirely different conversation. Maybe one of our episodes forthcoming, fingers crossed, on Code Whisperer, etc., might cover that as well too. One of our we got a couple of questions actually are coming through in the end. Somebody gave us a nice love heart and a poetry comment. We do appreciate that. I think that was in regards to your demo. Fair play, Igor.
Thank you.
All very good. Bigger one here, and this is, we're not going to be able to do this now, obviously, on this episode, but it is something that we have a lot of content for. So I think the best thing in answer to that essentially is we have the MongoDB Developer Center, where we have all of the DevRel team, our engineers, our product team, etc., creating tutorials. So if you go to developer.mongodb.com, you're certainly going to find out more around that microservices question that you did ask. If you have specific questions, here's my few plugs towards the end of this stream. You can come to our community forums, where our engineers, our DevRel team, and others hang out, and mostly our community are really responsive in answering those questions as well too. So if you have something specific for something that you're working on, a project or proof of concept, you get a ton of help at community.mongodb.com. Key for us, actually, based on our conversations here, is understanding more about MongoDB and AWS together. So we have that page there. If you go to, all our short links are mdb.link, but if you go to MongoDB on AWS, so mdb.link/MongoDB on AWS, you'll figure out everything that we have together. Igor's a regular on this show. Thank you so much, Igor. But in terms of everything that we do together with AWS, you'll see back on that developer center as well too. You'll see articles that Igor has authored or co-authored with some of the team as well. We do an awful lot together. We've got a ton of integrations. You would have seen them at the first slide that Igor presented there too. And if you're not on MongoDB already, or not using MongoDB and not on Atlas, but you are using AWS, you can use MongoDB via AWS through the marketplace. So if you go there, mdb.link/MongoDB-AWS marketplace, you can use MongoDB there, and there's no extra billing involved, etc., etc. It's all run through AWS. So we're trying to make life for developers super easy.
Actually, I want to jump in, Shane. That index vector search is working on the free instance. Well, a whole demo today I did, it was a free instance, a free tier instance. Yeah. Vector search and keyword search both are working on the free tier instance.
Okay, excellent. That's good to know. We did get one question, which is probably for myself and Dominic pretty much, is, what are the top 2 strengths of MongoDB with AI? The vector search capabilities of MongoDB Atlas now are the linchpin of everything that we do with AI. Dominic mentioned and Igor showed earlier that essentially we're storing the vectors in with your data that is accessed together should be stored together. That mantra, we're still going to use that one. But we have huge amount of integrations, as across the board with all of the large LLMs, the OpenAI's, Hugging Face, LangChain, LambIndex, etc. as well too. And it makes it really, really straightforward, regardless of what generative AI applications that you're building, is that the vectors that are generated from your embeddings are stored alongside the original data. That's our key benefit and just check out MongoDB Vector Search up on our website. You'll learn a lot more there as well too. Any other questions come in? No, some thanks and praise. We appreciate that. LinkedIn user, we can't give you a shout out. Please log in properly. But we appreciate that. As I said at the beginning, we do these Cloud Connect shows every week. It's not always Igor, as much as we'd love to have him on board all the time.
Something to improve.
He's a day job, right? So he can't join us, but very regularly he's on board, and you can check out the past episodes that we've done with Igor. And if you enjoyed this stream, please, like and subscribe, obviously, to the MongoDB YouTube channel, so you'll get the alerts for future streams coming up. Any final words or comments, Igor, for the audience here, or indeed Dominic as well too? Any comments?
Yeah, just have no fear. Try it out. Add it to your app. Play with it. Yeah, there's nothing to be afraid of. No barriers to entry.
It's all just a playground. I can only second that what Igor said. And yeah, thank you very much for being here, Igor, and showing us yet another cool thing and a cool demo. And I can't wait to see people try it out and build stuff with it and figure out what you can do with it. I'm gonna soon dig deeper into that myself again. And there's so much more that we can do with all the upcoming things. And the teasers that you gave us today already. So I'm really looking forward to that.
Awesome.
Excellent. Well, look, as ever, you made my role and job here as the host for this super simple. Dominic and Igor, thank you very much. If we whetted your appetite, please, jump onto SageMaker, play around in there. As Dominic says, it's a safe area. Go and break things. You need to experiment. And I think the key thing, and I think, Igor, you mentioned this to me in a previous chat we had, was just get started. There isn't anybody out there with, okay, you might have a few years of machine learning experience, but in this world of generative AI, everything's new. And you can go in there and look up all the resources and just get into that sandbox and start playing around.
Absolutely.
Excellent. Well, look, from everybody here on MongoDB TV, Dominic, Igor, thank you so much. From all of us, we do appreciate everybody who joined in, everybody who raised questions and comments. We do appreciate it. Thank you so much. Please stay tuned for future episodes. But for now, from us, from Igor, Dominic, and myself, Shane McAllister, for Cloud Connect on AWS, thank you so much for joining us. We do appreciate it. See you next time.